Greetings to all present. I am here to present the paper titled Consolidating Construction Loads, a Future Pathway to Sustainability. I am Kamal Dhawan, the presenting and corresponding author for the paper. During the presentation, I will talk of the construction industry in general and the New Zealand construction sector in particular, construction supply chain and logistics, sustainability in construction, sustainability in the construction supply chain and construction logistics, construction transport, the research opportunity that triggered writing this paper, and possible research directions presented by the research opportunity. The construction industry has certain typical characteristics. It moves to where work is and is project based, each project being unique. It entails repetitive reconfiguration of the supply chain, which is customized to the project, the execution phase, and the actors involved. It is highly fragmented and individualistic. Construction materials are low cost and high volume, and transport is fundamental to its operations. The barriers to sector transformation are complicated and unwieldy hierarchies, leading to adversarial relationships, lack of a coherent business strategy, the operations being precedence based, the tendency to pass risk rather than eliminate or share it, best for individual attitude rather than best for project attitude, delineation of the design and production processes, highly competitive tendering, and scarce use of technology. The New Zealand construction sector is isolated from the rest of the world owing to its peculiar geographical location. It responds comparatively slowly to improved philosophy, resulting in delayed introduction of new ideas. This typically lags UK initiatives by about 8 years. In turn, new initiatives to upgrade construction have major knowledge, understanding, and skills deficits. Its productivity compared to peer domains has not been very encouraging over the last about 30 years. In April 2019, the Construction Sector Accord was launched between the government and industry leaders, creating a platform for them to work together to meet some of the key challenges, including skills and labor shortages, unclear regulations, lack of coordinated leadership, uncertain pipeline of work, and a culture of shifting risk. This was followed up by a 3-year construction sector transformation plan during January 2020, a blueprint for resolving the sector's long term challenges around risk, overly complex contracts, and skills development. Construction supply chain management is a system where actors work together to install and utilize information to produce and deliver materials, plant, temporary works, equipment, labor, and other resources for construction projects. It primarily consists of owner, user, architect, consultants, and direct and indirect suppliers or contractors, and focuses on managing the interface between the supply chain and the site, managing the supply chain, transferring activities from the site to the supply chain, and integrated management of both. It has key considerations ranging from data processing to understanding financial trade offs at the other end of the spectrum. It is achieved at the operational level through an equitable relationship between actors, whereas at the strategic level, it is based on power relationships. Logistics plans, implements, and controls the forward and reverse flow and storage of goods, services, and related information between the point of origin and the point of consumption. It is considered a subset of supply chain management, though there are varying opinions. Construction logistics consist of whole projects, supply, and on site logistics. The Brundtland Report defines sustainability as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. It is comprised of the natural environment or planet, society or people, and economic performance or profits, referred to as the triple bottom line. Sustainable construction aims to restore and maintain harmony between the natural and built environments, adding value to quality of life by embracing economic and social domains in addition to the environmental domain. It applies sustainability principles to every stage of the project life cycle, with conscious design to decrease effects on consumption of natural resources and ecological systems. It stands at the cusp of sustainability in processes, use of resources, and application of principles. New Zealand is a signatory to the Habitat Agenda, therefore, commits to bring the impacts of the construction industry into harmony with the environment. Sustainable construction in New Zealand has a three-pronged approach, including government programs such as the Sustainable Development Programme of Action and legislation such as the Resource Management Act, inclusion of sustainability in the corporate agenda by industry coalitions, and knowledge management by professional and academic bodies. Sustainable construction management has many implementation contexts within and outside the construction domain, from governance and strategy through planning, project delivery, supply chain and logistics, operations, end of life, and waste management. It is associated with every stage of the project life cycle, from inception to handover and subsequent use. Implementation attributes are iterative development, early stakeholder involvement, communication, coordination, collaboration, value generation, and waste removal. Strategies such as the lean project delivery system, integrated project delivery, and agile project management have been adopted from the manufacturing domain. Relational project delivery arrangements have emerged in the construction industry since the 1990s in the form of partnering, alliancing, and integrated delivery. Impact assessment in New Zealand has moved from environmental impact assessment to complete sustainability assessment with tools like sustainable return on investment, economic value added, sustainable value added, and sustainability appraisal. Sustainable construction supply chain management is characterized by integration of economic, environmental, and social considerations with key inter-organizational business systems designed to efficiently and effectively manage operational delivery to meet stakeholder requirements and improve profitability, competitiveness, and resilience over the short and long terms. It has multifarious attribute categories associated with each of the three BL dimensions, spanning across performance and parameter efficiencies, profitability and equitable distribution, and social compliance and HR issues. The basic model revolves around strategic orientation to 3BL and supply chain management, a framework of continuity in relationships and business development, collaboration in strategy and operations, and processes centered around risk management, stakeholder management, innovation, and the life cycle perspective. Logistics at the delivery end are characterized by fewer and shorter movements, lesser handling, better vehicle utilization, and energy efficiency. The New Zealand context, formalized in the Energy Strategy to 2050, agrees with this, with sustainable transport forming the linchpin of operational implementation. Construction material being low cost and high volume, transport is a major component of construction logistics. Estimates show that transport is responsible for nearly half the construction logistics cost, about one-fifth of the construction costs, and almost a tenth of the selling price. In addition, it is a major energy consumer and significant generator of emissions. Construction transport consumes nearly 40% of urban oil, causes between 16 to 50% of urban pollution, and leads to many times higher fatalities compared to other modes of transport. Related negative social and environmental impacts are damage to biodiversity, noise, congestion, accident risk, gridlock, adverse public health, to name a few. Effects of transport within and outside the domain are therefore substantial, and optimization can have a major positive contribution in terms of reducing or mitigating negative impacts. In the New Zealand context, freight transport is a major contributor to the greenhouse gas emissions annually, and negative social and health impacts such as pollution, noise, crashes, and community disruption. The research opportunity has been provided by WaterCare, an Auckland Council owned entity providing water, wastewater, and stormwater services across Auckland. They have recently commenced a program to deliver capital water infrastructure in the Whangaparoa Peninsula under a $2.4 billion contract with their supply chain partners over 10 years. It adopts program alliancing as opposed to project by project alliancing from the enterprise model of Project 13 of the UK as a strategic infrastructure delivery vehicle. At the operations end, it has adopted the Construction Consolidation Center approach as a logistics solution. Both the initiatives are a first in New Zealand, the portfolio based delivery being a step change in infrastructure procurement. Aiming at 40% carbon and 20% cost reduction by 2024 and 20% health and safety improvements year on year, they create a unique contextual research opportunity, permitting performance benchmarking against previous research in Europe, continental USA, and Australia. Research possibilities from a CCC-based logistics solution under collaborative delivery in New Zealand may be many. With environmental and social considerations taking root in policy and legislation, construction needs to become sustainable. Sustainability implementation initiatives drive transport research within logistics to serious relevance, while a new dimension of collaboration emerges from innovative project delivery. The graphic shows possible research domains, research questions, and outcome possibilities from the center outwards against the 3BL backdrop. These are by no means exhaustive, and many more may be drawn from this unique contextual research opportunity.